You look up at the night sky, and there it is, that familiar silver disk. It's guided sailors, inspired poets, and for as long as we've been human, it's marked the passing of our time. But our planet's only natural satellite, our constant companion, is so much more than just a pretty light in the dark. So today, let's really get to know the moon.
Think about it. It's been circling our planet for 4.5 billion years. It shapes our calendars, our tides, our myths, but behind that familiar face lies a history of incredible cosmic violence and a truly, truly alien landscape. So how well do we really know our closest neighbor? Let's find out.
All right, let's dive right in with a fundamental puzzle, one you've probably noticed yourself just by looking up.
Have you ever realized that the man in the moon, or whatever shapes you see up there, is always the same? No matter where you are on Earth, no matter the season, the moon always shows us the same face. Now, that's not just a coincidence. Nope, it's physics on a cosmic scale.
What's going on here is this amazing celestial dance called synchronous rotation. You see, over billions of years, Earth's massive gravity has been playing a long game of tug-of-war with the moon, slowing its spin down until it locked into this perfect rhythm. It takes 27.3 days to go around us, and it takes 27.3 days to spin once on its axis. They're perfectly in sync. This is called tidal locking, and it's the reason the far side of the moon was a complete mystery to us until we finally sent a spacecraft around to look in 1959.
Okay, so we know why it's locked to us, but how did our companion even get there in the first place? Well, the answer isn't a gentle one. It's a story of planetary chaos and a collision of almost unimaginable scale. The leading theory, and honestly, it sounds like something straight out of a blockbuster movie, is called the giant impact hypothesis. The idea is that about 4.5 billion years ago, when our solar system was basically a chaotic construction zone, our young Earth didn't have a moon. What it did have was a collision course with another baby planet, a world about the size of Mars that we've named Theia. And the process was just catastrophic. Imagine an impact so powerful it basically liquefied both planets, sending this colossal spray of molten, vaporized rock blasting out into orbit around Earth. And from that superheated cloud of debris, gravity started to do its slow, patient work, pulling all those tiny fragments together, piece by piece, until they coalesced into the sphere we know and love today. And this incredible theory didn't just pop up overnight. For decades, scientists were totally stumped. This quote here really captures a turning point. It was a challenge laid down before a big conference in 1984, and it worked. That conference is where the giant impact hypothesis really came out as the clear frontrunner, because it was the one that best explained all the new, crucial data that the Apollo astronauts had brought back from the moon. So after that violent birth, the moon settled into a much quieter existence. But let's be clear, quiet does not mean hospitable. In reality, our celestial neighbor is a truly alien world. Just look at this comparison. It really puts things into perspective. Here on Earth, we're cozy under a thick, protective atmosphere that regulates our temperature and lets liquid water exist. The moon? It has basically no atmosphere at all, which leads to these absolutely wild temperature swings. A single lunar day can go from scorching hot enough to boil water to unimaginably bone-chillingly cold, and any water it has exists only as solid ice, hidden away in craters that are permanently cloaked in shadow. Even the ground itself tells a story of two different worlds. You know those dark patches we see, the Maria or seas? Those are vast, ancient plains of cooled lava, basalt flows that are rich in heavy elements like iron. But the brighter areas, the Terra or highlands, that's the moon's original older crust. They're lighter in color because they're full of lighter elements like aluminum. This difference is like a geological fingerprint, a direct clue to the moon's molten past.
Now you might be thinking, okay, so it's a dead world. Why does it matter so much? Well, the thing is, the moon's influence is absolutely vital for life here. Its gravity is what pulls on our oceans, creating the tides. It's even ever so slowly slowing down our planet's rotation, making our days longer. But maybe the most important job it has is acting as our planet's stabilizer. Without the moon's constant gravitational pull, Earth's axis would wobble all over the place, making the stable climate that allowed life to flourish totally impossible.
So of course, this strange, powerful, and alien world has been calling to us for centuries, and eventually we answered. Let's take a look at the brief but incredible history of humanity's journey to actually touch our celestial neighbor.
For thousands of years, all we could do was watch and wonder. But in the 20th century, everything changed, and it changed fast. The space race kicked off this rapid-fire series of incredible milestones. First, the Soviets' Luna 2 became the first human-made object to even reach the moon. Then, of course, the historic Apollo 11 landing. And it continues right up into the modern era with China's amazing and groundbreaking landing on the far side, a place no one had ever touched before.
382 kilograms. That might just sound like a number, but that's the total weight of moon rocks and soil that the Apollo astronauts brought back to Earth. And this isn't just a collection of stones, it's a physical library of our solar system's history. These precious samples are what confirmed the giant impact theory and have been absolutely fundamental to understanding not just the moon, but the ancient past of our very own planet.
But then, after the Apollo program ended, human exploration just stopped. For decades, only robots have made the journey back. But now, after a 50-year lull, that is all about to change.
We are, right now, entering a brand new era of lunar exploration, a new moon rush. And this time it isn't just one or two nations, it's a global effort, with governments and private companies all getting in on the action. So why now? Well, a huge driver is the discovery of water ice at the poles. That ice is a potential game changer. You can use it for drinking water, for breathable air, even for rocket fuel. It could be the key resource for building future lunar bases, all governed by a treaty that says the moon is for everyone and for peaceful exploration. So we end up right back where we started, looking up at our neighbor. But now we see it a little differently, don't we? It's not just a light in the sky, it's a record of our violent past, and, just maybe, a stepping stone to our future in the cosmos. What will we find when we go back for good? And what will that mean for all of us, down here on Earth? Well, that's the next chapter, and it's just waiting to be written.